Ferrari's so-called engine trick for 2026 is not a gimmick or a shortcut, but the result of a calculated technical and internal response to what they believe could define the next era of Formula One before a single race is even run. At the center of this story is the discovery that Mercedes and potentially Red Bull powertrains have found a legal interpretation of the new regulations that allows their engines to operate with a significantly higher effective compression ratio once at full operating temperature, despite passing all FIA checks at ambient conditions. The potential lap time gain from this interpretation, estimated at around 3/10 N of a second, immediately set alarm bells ringing in Maranello. Under the 2026 regulations, the compression ratio of the internal combustion engine is kept at 16:1, a reduction from the previous 18:1 limit. However, the rules specify that this ratio is measured under defined controlled conditions, creating an opening for teams to exploit how materials behave when exposed to extreme temperatures and pressures during real operation. Mercedes are believed to have designed their combustion system so that thermal expansion effectively increases compression once the engine reaches race conditions without violating the letter of the regulation during inspection. Ferrari, alongside Honda and Audi, quickly identified this approach as a grey area interpretation that, while technically legal, challenges the spirit of the regulations. The concern was not simply about fairness, but about competitive balance at the start of a new regulation cycle. A 310th advantage from the engine alone could effectively decide championships before aerodynamic development even begins, forcing rivals into years of recovery. This triggered a multi-layered response from Ferrari. On one level, they applied internal pressure by formally requesting clarification from the FIA, pushing for a tighter definition of how compression ratios should be controlled throughout all phases of competition, not just during static checks. Ferrari's position is that a Formula One car must comply with the regulations at all times, including at full operating temperature, a clause already present in the rule book, but open to interpretation. At the same time, Ferrari prepared for the possibility that the FIA would allow Mercedes' solution to remain legal, at least for 2026. Rather than waiting passively, Ferrari accelerated work on their own counter-solution. One that does not rely on exploiting temperature-based loopholes, but instead on fundamental metallurgical strength. This is where Ferrari's true engine trick emerges: the decision to commit fully to a steel alloy cylinder head. In modern Formula One, aluminium cylinder heads are preferred because they are lightweight and easier to cool. Ferrari initially developed such a solution in parallel. However, aluminium reaches its structural limits far earlier when subjected to the extreme pressures required by the new 2026 combustion targets. Ferrari's engineers realized that to safely push combustion pressures higher, they needed a material capable of surviving conditions that aluminium simply could not endure over multiple race weekends. The steel alloy cylinder head Ferrari have now approved is heavier but vastly more robust. Incorporating elements such as copper and ceramic composites, it allows Ferrari to experiment with combustion pressures and temperatures that were previously considered unrealistic in Formula One. This gives Ferrari the ability to chase performance through brute force engineering rather than regulatory interpretation, staying comfortably within the rules while still extracting meaningful gains. This decision becomes even more logical when viewed in the context of the 2026 power unit, its increased minimum weight. The new engine is expected to weigh around 150 kg, roughly 30 kg more than current units. That additional allowance reduces the penalty of heavier materials, making steel a far more viable option than it would have been under previous regulations. Ferrari's engine leadership, headed by Enrico Gualtieri with David Madzone overseeing the 2026 project, and Guido Di Pa returning to a more hands-on technical role, reflects how seriously this solution is being taken. The steelhead was not approved lightly. It followed extensive collaboration with AVL, one of the most respected engineering firms in high-performance combustion development, to ensure reliability across 4 power unit allocations per season. This approach contrasts sharply with Mercedes's solution. While Mercedes appear to be exploiting material behavior to achieve higher effective compression indirectly, Ferrari are choosing to physically reinforce the engine to tolerate higher
As we move forward, it's
loads.
crucial that we align our strategies with the current
philosophy,
market demands.
Precision exploitation versus structural dominance. Ferrari's belief is that over a full season, reliability and consistency will outweigh any early peak advantage. The implications extend far beyond the engine itself. Higher combustion pressures increase thermal load, but Ferrari's steel solution allows more predictable heat management. This enables tighter control over cooling requirements, allowing smaller radiators and more aggressive aerodynamic packaging. In 2026, where drag reduction and energy efficiency are paramount, this integration between engine and aero becomes a major competitive weapon. Ferrari's power unit has been designed entirely in-house at Maranello, giving them an unusual level of integration between departments. Aerodynamics Amicists Diego Tandy and Frank Sanchez have been working closely with the engine team to exploit the compact layout enabled by the new design. Smaller radiating masses and a lighter battery package allow cleaner airflow and more extreme bodywork concepts, something Ferrari consider essential to offset any engine deficit. Ferrari's pressure on the FIA remains ongoing. There is a real possibility that a technical directive could be introduced after the opening races of 2026, forcing Mercedes and Red Bull to modify their engines mid-season. Such a move would be controversial, but Ferrari and their allies believe allowing a potential loophole to decide a championship would be worse for the sport's credibility. If such a directive were introduced, Mercedes could be forced into a rapid redesign, disrupting reliability and performance. Ferrari, by contrast, would already be operating within stricter boundaries, giving them a strategic advantage. Even if no directive arrives, Ferrari's steel-based solution ensures they are not forced to chase a moving target throughout the season. What makes this engine trick genuinely fascinating is that it exists far beyond the boundaries of pure engineering. It sits precisely at the point where technology, regulation, and internal collide, which is where modern Formula One is often decided long before cars line up on the grid. Ferrari are not simply developing hardware in isolation. They are navigating a complex ecosystem where legal interpretations, regulatory wording, and competitive timing are just as influential as metallurgy or combustion theory. Their response to the Mercedes compression solution shows a team fully engaged in this multi-dimensional battle, prepared to defend its interests not only in the Dino room, but also in design meetings and behind closed doors at the FIA. This approach reflects an understanding that in a regulation reset as extreme as 2026, the championship can be lost before the first race if one concept is allowed to run unchecked. Ferrari recognized that allowing a potential 3/10th engine advantage to exist would fundamentally distort the competitive landscape. As a result, they are fighting on parallel fronts, challenging interpretations they believe undermine sporting fairness, while simultaneously ensuring they are not left exposed if the FIA ultimately allows those interpretations to stand. It is a dual strategy designed to protect Ferrari regardless of how the internal outcome unfolds. The technical risks involved in Ferrari's chosen path are far from trivial. Steel alloy components introduce additional mass, increased inertia, and greater demands on cooling and packaging, pushing combustion pressures and temperatures into previously unexplored territory, amplifies mechanical stress across the entire power unit from pistons and valves to the crankshaft and hybrid integration. These are not marginal challenges that can be solved late in development. They require absolute confidence in materials, manufacturing tolerances, and long-term fatigue behavior. Ferrari are effectively betting that their understanding of these variables is strong enough to survive the harshest conditions a Formula One season can deliver. This is why durability has been elevated to a central design pillar rather than a secondary consideration. Ferrari know that in the new era, peak performance is meaningless if it cannot be sustained across multiple race weekends and power unit allocations. Their decision to prioritize robustness before chasing maximum output suggests a mature acceptance of the realities of 2026. Reliability is no longer just about finishing races. It is about preserving strategic flexibility and avoiding the cascading compromises that follow early failures. This calculated aggression perfectly captures Ferrari's mindset heading into the new regulations. By effectively abandoning meaningful development of the 2025 car, Ferrari committed fully to the belief that 2026 would define their future. That decision carries enormous
As you can see from the
pressure
latest projections, our
internally.
growth trajectory is exceeding
Anything
expectations.
short
That's
of
a significant
competitive
improvement. What are the
power
next steps?
It would not merely be a disappointment. It would represent a failure of strategic judgment at the highest level. The engine, therefore, has become the structural spine of the entire project, the component upon which all other ambitions depend. If Ferrari's approach succeeds, the implications extend far beyond neutralizing a perceived Mercedes advantage. It would demonstrate that brute force engineering rooted in material science and structural resilience can compete with and potentially outperform more delicate solutions based on exploiting regulatory gray areas. Such an outcome would reshape how manufacturers approach power unit design in the hybrid era, shifting emphasis toward physical robustness as much as software sophistication and energy management algorithms. This is why describing Ferrari's solution as an engine trick is both appropriate and misleading. It is not a trick in the sense of concealment or manipulation, but in the sense of applied intelligence, a willingness to rethink fundamentals and pursue solutions others may have dismissed as impractical. Ferrari are not bending the rules to gain an edge. They are hardening themselves against the rules, building an engine capable of thriving under the most demanding interpretations of the regulations. As the 2026 season approaches, the true consequences of this decision will only become apparent once engines are subjected to full race intensity. Dyno numbers, simulations, and test bench validation can only go so far. The real test will come when steel components endure repeated heat cycles, sustained high loads, and the unpredictable stresses of wheel-to-wheel racing. It is there, not in press releases or paddock rumors, that Ferrari's gamble will be judged. If the steel-headed power unit delivers the balance of durability and performance Ferrari expect, it could quietly dismantle what many assume to be an inevitable Mercedes advantage, not through spectacle or controversy, but through relentless consistency and structural superiority. And in doing so, it could redefine the competitive order of the new era without ever making headlines for the wrong reasons. Because in Formula One, the innovations that change everything are rarely the ones that arrive with noise and drama. They are the ones that seem unremarkable on paper, unforgiving in execution, and devastatingly effective once the lights go out and the racing begins. In this,